In this video, let us try to solve these two problems. Here we have to apply the sum and difference formula of trigonometric functions. Please pause the video and give it a try yourself, then you can come back and look for the solution. So in the first question, the value of tan B is given, which is n sin alpha times cos alpha divided by 1 minus n sin square alpha. Using this information, we have to prove that tan of alpha minus beta is equal to 1 minus n tan alpha. So let's write the formula of tan of alpha minus beta. So this will be equal to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Now let's substitute the value of tan beta here, and let's change tan alpha to sin alpha by cos alpha. The reason is the value of tan beta is expressed in terms of sine and cos. So this will be sin alpha by cos alpha minus n sin alpha cos alpha divided by 1 minus n sin square alpha divided by 1 plus, now again tan alpha can be written as sin alpha times cos alpha multiplied by n sin alpha cos alpha divided by 1 minus n sin square alpha. Now let's solve for the common denominator. So the numerator would change to sin alpha minus n sin cube alpha minus n sin alpha cos square alpha divided by cos alpha times 1 minus n sin square alpha. Now the denominator would be cos alpha minus n sin square alpha cos alpha minus n sin square alpha cos alpha, this divided by cos alpha times 1 minus n sin square alpha. So we can cancel this out, cos alpha times 1 minus n sin square alpha. Now in the numerator we can have n sin alpha as a common factor. So this will change to sin alpha minus n sin alpha as a common factor, and the first term would be sin square alpha plus cos square alpha divided by, here in the denominator, sorry, there is an error, this is a plus value because it's plus here, so these two values gets cancelled, so we will have cos alpha in the denominator. Now this will be equal to 1 because of the trigonometric identity sin square alpha plus cos square alpha is equal to 1. So now we will have sin alpha as common, and it is 1 minus n divided by cos alpha. This is equal to tan alpha times 1 minus n. So this is the value of tan of alpha minus beta. So this is the proof we were required to find out, and we have implemented the subtraction difference formula of tan of a minus b. Let's try the second one now. Let's try to prove the second one. Here we have to prove that cos square a minus b plus cos square b minus 2 cos a cos b times cos of a minus b times cos a cos b is equal to sin square a. Now if you observe here, the first term and the third term has cos of a minus b as a common factor. So we can write this as cos of a minus cos square b, then we can have plus cos of a minus b as a common factor, and this would be cos of a minus b minus 2 cos a cos b. Now let's apply the formula of cos of a minus b. So this would be cos square b is plus cos of a minus b, and this would be cos a cos b plus sin A Sin B minus 2 CosA cos B. Now let's subtract this. So we would have cos square B plus cos of A minus B. Then this would be sin A sin B minus cos A cos B. Correct? So sin A sin B minus cos A cos B is cos of, how can we write this? So this would be minus cos of, this is cos square B plus cos of A minus B. This would be minus cos of A plus B. So this will change to cos square B minus cos of A minus B multiplied by cos of A plus B. Now cos of A minus B multiplied by cos of A plus B would be cos square B minus cos square A minus sin square B. So that is a formula. Please refer to the formula sheet in the previous videos that we have listed out. So this will be cos square B minus cos square A plus sin square B. Now cos square B plus sin square B, this will be equal to 1. So this will be 1 minus cos square A, and this is nothing but sin square A, because sin square A plus cos square A is equal to 1. So this is how we can prove the second question by applying the difference formula of cosine function. So please try such questions. I have listed out many videos. I have published many videos. You can solve each one of them and get the skill to solve these questions. Thank you so much for watching. I'll see you in the next video.